In the third page in your packet, you will see a diagram that looks like this. We are going to now go on to topic 3, which is naming polyatomic roots. Now, we've already learned how to name a binary, and a binary means two things, such as sodium chloride. The first element is a metal, and the second element is a nonmetal. If there is no oxygen present, then we change the ending to IDE. So the chlorine becomes chloride. So the name of this would be sodium chloride. But with polyatomics, you have usually oxygen bonded. Polyatomic means many atoms. So, for example, suppose instead of Cl, we had ClO3. The Na is still called sodium, but now we have to name this ClO3 part. If it contains the most common number of oxygens, you change the ending to 8. So, everything on the periodic table wants to have 3 oxygens. If it gets the 3 oxygens, then you change the ending to 8. That's what I mean by the most common number. So chlorine wants 3 oxygens. It gets 3 oxygens. So I change the ending to chlor 8. So that would be named sodium chlorate. Now what about if you had ClO2? Chlorine wants to have 3 oxygens, but it doesn't. It gets 2. It has 1 less than what it wants. If it has 1 less than what it wants, I would change the ending to ite. So it becomes chlorite. And still sodium. What if you have 2 less oxygens, ClO? Again, the chlorine wants 3 oxygens, but in this case it only has 1. It has 2 less than what you want. If it has 2 less than what you want, then you would change the ending to hypoenite, and it becomes hypochlorite. And what if you have 1 extra, ClO4? If you have 1 extra than what it wants, then you change the ending to per and ate. So this would be per is the prefix, chlorine, and then change the ending to ate. Perchlorate, sodium perchlorate. So like I said, everything on the periodic table wants to have 3 oxygens, except there are 4 exceptions. And these 4 exceptions are passes. Phosphorus, arsenic, selenium, and sulfur, they all want 4 oxygens. So everything else wants 3, except for these 4 want 4. So in this case, if you had PO4 with a 3 minus charge, PO4, the phosphorus wants 4. So if it wants 4 and gets 4, the name would be phosphate. What about if you had PO3 with a 3 minus charge? It has 1 less than what it wants. It wants 4, it has 1 less. This would be called phosphite. And 2 less, PO2, be hypophosphite. Now how did I know the charges? The charges are the same as in their group. So chlorine is in the -1 group, so chlorate would be in the -1 group. Sodium is a +1, and so they are balanced that way. So just to recap, if it has no oxygens, you change the ending to "ide." If it has the number of oxygens it wants, you change it to 8. If it has one less oxygen than what it wants, you change it to "ite." Two less oxygens than what it wants, you change it to "hypo" and "ite." And if you have one more oxygen than what it wants, you change it to "per" and "ate," except for passes. Those 4 elements want 4. The 4 that want 4 also happen to be all right next to each other. Passes. Phosphorus, arsenic, selenium, and sulfur. As I said before, everything else wants 3 oxygens on the periodic table, and they follow the same charges in their group. So fluorate, chlorate, bromate, and iodate all will have a -1 charge, as well as fluorite, chlorite, bromite, and iodite. Sulfur, sulfate, sulfite, hyposulfite, selenate, selenite, they will all have a -2 charge. Phosphate, phosphite, arsenate, arsenite, they will all have a -3 charge. The only exception would be boron, carbon, and nitrogen. Those 3 want 3 oxygens, however, they don't follow the same charge as their group. But there is a little bit of a pattern. Borates and borites all are -3, carbonates and carbonites are all -2, nitrates and nitrites are all -1. And of course, if you get stuck, you can always look on Appendix A. They have all the charges on Appendix A. Because there will be some weird ones, like permanganate, or oxalate, or acetate, where you just have to simply look up. Now, how do you balance, how do you go from the formula to the name? Let's just do a couple examples. Suppose you had this. First you do is realize this breaks into 2 parts, the metal part and the non-metal part. You name your metal part. Fe is iron. Now iron can be more than 1 charge. Iron can be a +2 or iron can be a +3. But the PO4 part, we know the name of that. Phosphorus is part of the gang of 4. Phosphorus wants 4 oxygens. So it wants 4 oxygens, it has 4 oxygens. The name of it would be phosphate. Now the charge on phosphate is a -3. Okay? So in order for this to balance, 2 times a -3 is a -6. 3 times, it would have to be a +2 in order to get a +6 in order to balance out. So this would be iron 2-phosphate. You never change what's inside the parentheses, okay? What's inside the parentheses always stays the same. So you do not alter the number of oxygens inside there or alter the phosphorus in any way. Now how about going the other way? From name to formula. Suppose we had aluminum sulfate. Now let's do aluminum sulfide. The symbol for aluminum is Al. Sulfite. Now sulfur is part of the gang of 4. It wants 4 oxygens. If it had 4 oxygens, the ending would be 8. But the ending is not 8, the ending is ite, which means it has 1 less oxygen. So it becomes, instead of SO4, it becomes SO3. put parentheses around it. We write a charge up here for the sulfite, which is a 2 minus. Charge on aluminum is 3 plus. Then we crisscross. The 2 goes down here, and the 3 goes there. Once again, you never change what's inside the parentheses. So the compound will be aluminum sulfite. Now for strange ones like sodium acetate, you just have to look up the formula of acetate on Appendix A. Sodium is a 1 plus, bless you. Acetate is C2H3O2 with a 1 minus charge. If you were to crisscross it, the 1 would come here and the 1 would go there. And then we erase our charges and we erase the number 1. Okay? What do you think? You agree, huh? All right. So you should be able to finish now worksheet number 3, top and bottom, and we'll push the binary quiz back off until tomorrow. Thanks much. Bye-bye.